Okay. So before we start this part of C language, so we discuss about that we have understood the basic things about C language. We have understood uh, how to write the program, very basic program of C language, where to write that program, what is editor, what is compiler, what is linker program, loader program, preprocessor program, how they are connected or synchronized in C program lifecycle, how to run that program, what is syntax error, what is runtime error, what type of runtime errors are there. And syntax errors are basically related to our syntax of the programming language. If we do not follow the syntax or rule as specified by the language, then we get syntax error. We have also discussed that what is IoT, in which or embedded systems in which C language is more used. When you have high mathematical calculations which are computationally intensive, then which language is better to use? If you want to go fast, then C language is better. If you want to reduce your complexity in your mind when writing the program, then other high level languages you can use. Okay, when you want to use more powerful language in which you can play with your hardware and the memory, then C language is the best candidate for that type of situation. What is the significance of as include stdio.h that we have discussed? So all these things are covered, and now we will discuss about basic data types. And before we go about this basic data type, first we understand that what is actually programming language, what it is helping us to achieve. So initially when computer systems were being developed, they were working or they were able to take instructions only in machine level language. And why we were trying to give them instructions? Because human beings have always been curious to give instructions, to develop machines which are intelligent. When a human being says something, then they should do according to the requirement of human beings. So since everything cannot be done by the machine, and machine were not so much developed as they are developed right now. So initially, small programs we were writing in assembly language program, assembly language, and in machine level language. And when we were writing, so that was very difficult task for any programmer, because everything which you were writing, that was actually in 0101 and 01. So which 01 combination is for which purpose, that was very difficult to understand. And because of that thing, we were not able to write big programs. So we were able to write very small programs, addition programs, subtraction program, division programs, like that. But then also we were having something in our mind that we should develop some instruction systems which in which we can give our computer systems uh, instructions, and we solve our real world programs. Okay, for example, if I want to write a program of a class in which I want to develop the mark sheet for each student, that in this subject this student has uh, the, this marks, in this subject this student has achieved these marks, like that. If that is the situation, so initially when we were writing the program in machine level, then it was nearly impossible to write such programs. So we were just initially beginning, and we were trying to do things which were only computational, like our calculator. Later on, we developed from machine level language to the assembly level language, where we started giving some keywords, that if you want to add two values, then we will use a double d. If you want to multiply, then we will use mult in place of 0101 combination representing these two keywords. So like that we started developing keywords, because to learn or to remember 01 is much more difficult than to remember. So we were actually doing that. We want to reduce the overhead or complexity of program writing. because we always wanted to solve real world problems using our computer systems, do our real world task using our computer systems. So the instructions which we are trying to give to computer system, they should be less complex and easy to understand. So from machine level language, we came to assembly level language. And when we came to assembly level language, so we were able to write little bit big program as compared to the machine level language. Then, but in between, one software came that is called assembler. So assembler meaning is that you write a program in assembly language and then it is converted into machine level language so that machine can run that program. Machine can run program only in machine level language. So in whatever language you want to write the program, you can write, but you have to develop a corresponding software so that when that software take that program written in particular language, it converts that program code, source code, into machine understandable format. So then after assembly language program, we developed other programming language like Fortran, C language, and we came to the stage of compiler. So, and then we again went to high level language programming, and then we again came to virtual machines, Java virtual machine, or some compilers or interpreter in between. So there is a translator in your computer system which translate your machine level language, high level language program into your machine level language program so that your machine can run those instructions. So that abstraction was created only because we wanted to write, give more instructions, make our computer systems more powerful, and to write program in a easy or better way without taking complexity, too much complexity into our mind. So that was the things they were going on when the development of programming language, compiler, and all these things were happening. So basically, if you see that we are writing programs because we want to automate something, and we want to automate something and we want to do that automation multiple times. Okay, so if I have written that uh, code in C language which can print the mark sheet for one class, then I can use the same program to print the mark sheet or to calculate the percentage, to calculate the attendance for whole semester for coming batches also. So that was the repetitive task and automated task that we want to do everything whatever we were trying to do manually using our computer systems or the machine. So that was our main purpose. So when we are using our computer systems, so we write program, and when you combine the programs and small programs and you develop a large functionality together in which multiple programs or so many programs are integrated, then you can say that becomes your software. So right now, whatever uh, we are doing this teaching using talk, so there are many functionalities in this going on right now, and there are multiple programs running, and that is why we are calling that this Zoom is a software, not a program. Although it is collection of the program, they are integrated properly so that they can function in a better way by providing the full online experience to us when I am teaching and you are listening, and we are able to share the screen. So if I am able to mute, then it is one small program. If I am able to unmute, then it is also that program. Okay, so that program is taking care of this functionality. Then when I am sharing, that there is one small component of the program, of software, that is actually helping me to share the screen. So like that, when we have integrated everything together and providing it as a package, so this becomes a software with your documentation, that which functionality is to be used in which manner, what are the installation requirements, on which operating system it will work and on which operating system it will not work. So like that it happens. After that, so what we have done is that we have given instructions according to our requirement. So in similar cases, we have here two things. When we are dealing in real world requirements, so we have data and we have the things which we want to do. So things which we want to do, they needs to be converted into a uh, in a way so that they can be written as a instruction in programming language. And when we try to deal with data is actually processed, modifications are done, and then it is displayed or stored. Like that, this situation happens. So you have actually two things. One is what is the data on which you want to express or you want to perform your operations, and what are the instructions which you want to perform. So in the previous program, Hello World, we haven't used any data because there was no requirement of the data per se. But we were giving the instruction to the computer system that we want to display this text, welcome to C programming language. But in real world, we also face requirements such as how to modify our data. If you are doing numerical computation in mathematics, so you have many methods there
Excuse me, sir.
for the numerical
Hello,
computation.
excuse me, sir.
Yes, sir.
Your screen is showing only best data type.
Yeah, sir.
It
I'm
not
just
showing.
I know because I am just discussing the philosophical part of this screen,
Oh,
and after that I will go in detail. Okay, so basically our part here is that we need data because we want modification in that data, we want processing of that data, and then we want instructions. Okay, so instructions we can write in our program, but how to take data, whatever is available in real world, into a programming language construct. How can we take integer type of, because we have data in real world, we have name of the student, we have name of the faculty, how to take that data and write the program. We have numerical things like we have marks which are real numbers, and we have age which is not in real number, which because we consider that is to be discrete number, that you provide always the integer detail. So your roll number, that is not a not a real number, it is an integer number. Okay, or it can be alphanumeric in which some part is uh, your is some characters, and then some part can be your integer. So if these type of requirements are there in real world, so how do you store these requirements when you are writing the program and then you are processing those requirements? So that is, and you need actually two things when you are understanding any programming language, that how will you represent your real world situation in the form of data, and then how do you modify that data so that you can get your desired result. So this is uh, what we will be discussing in this slide.